Welcome to our e-learning platform Origins e-Shala. This is going to be a playlist specifically for MBA aspirants. This is not going to be towards a single MBA exams as such CAT, ZET or any other, but a general foundation topic for several such exams. Here we are going to start with the number systems, as it is a very core concept required for almost every entrance exam that you can see listed down here. CAT, ZAT, NMAT, all of these exams need this as a foundation. But mind well that obviously in no CAT exams or any aptitude exam, you are going to get questions from this directly straightforward. There will always be a combination of several topics where this will help you to evaluate or solve that question faster if you have the knowledge. There are no such questions where they are asked directly, but always an indirect approach is used for the what we can say your selection process by asking such combination questions with this topic as a foundation. And of course I will try to distribute this topic, in fact all the topics, in a 15-minute video sections, so you may know when you have to take a break, because human brain cannot average human brain cannot pay attention for more than 15 minutes. So after 15 minutes take a 5-minute break and come back and you can continue with the next lecture. So minding that, I will try to keep them around that time. And of course, as this is for MBA aspirants, the language is going to be English, because when you are going for MBA, this is, I think, the basic level of communication skill that you must have, at least to understand what I'm saying. And of course I will also try to make it as simple in the communication matter, so you won't struggle much. So with that said, for number systems, these are the topics that we will be covering, like number tree, factors, factorials, etc. And if there are any topic you may think that you already know, that mind well, we are going to be discussing the shortcut tricks which will be helpful for solving these topics faster, or some related topics to them, not directly like how to find LCM. You know how to find LCM already, right? So these are the topics, and if there is a topic you don't know, don't worry, we will also be going over that. Now as I said, number tree would be the first topic, and many of you who are from science might already be knowing that numbers can generally be classified as either imaginary or real. Now imaginary are numbers which cannot be used for counting the physical things in nature. Like let's say I have written here I square is equal to -1. So if I take this square to the other side of equal, what will it become? Under root of -1. Now think about it and tell me in comment section, is it possible for any real quantity, either money, fruits, vegetables, anything that you may be able to count, is it at all possible for them to be in a quantity of root of minus negative some number? No, right? So that's why these category of numbers are termed as imaginary. They have no real physical purpose, at least, but for several scientific calculations that I think science students might be quite acquainted with, are useful. Now there are not many questions which come around this topic. Even if they come, they are very basic level, so you don't need to worry about imaginary numbers even if you don't know them. Similar questions which need this topic, we will discuss them at a later stage, but our major focus would be real numbers. Now real numbers, as I said, is the opposite of imaginary. Anything that can be counted or quantified, like money, credits, or anything at all which you can count, are real, and obviously they are used in real world, so real numbers. Now first category within them is rational numbers. It's for its explanation, I think the term written in bracket is quite simple, like any number which can be expressed in a fractional form like p by q, where the denominator cannot be 0. Denominator means the number below, which is the bottom of the fraction. That is denominator for those of you who don't know. So it cannot be 0 because the value will tend to infinity otherwise. So any number which can be expressed in a form of fraction, that is rational. In that category, we have the most basic numbers, complete numbers, or you can say integers. And they are first that everyone knows, that are whole numbers, from which basically our calculation started. So without any numbers, what will be there? That will be 0. And up after that, from where our calculus started, that would be natural numbers, which was used in ancient days for counting money, credits, and everything. So with that said, I think this is very clear and very basic thing that most of you might be knowing, that we have 0 and natural number, and together they form whole number, and together with negative numbers as a complete set, they form the integers, like minus infinity to 0 and then again to positive infinity. All this range of complete numbers, they form the integers. Apart from integers, we also have within rational itself non-integers, like the numbers which are not a complete set, which does not occur naturally. For example, most of you might have known the example of an apple being cut in three between three people and similar things. So apple as a nature come as a whole single entity, we are distributing it, so it becomes portion. So those portions are either represented as fractions or decimals. Both are indicating the same things, just the representation is different. So fractions, as you might have known, they are in form of numerator and denominator with a dash or line in between, and for decimals you have a point in between. So decimals can also be a two kinds. First is terminating, which just end like 0.56, 0.7. After that, we all know they are only zeros, so we don't represent them. But some numbers never end, but they do have a sense. Let's say 1 by 3, for example. 1 by 3 itself is a fraction, but when you convert it to some numeric value, you will get 0.33333 and so on. So this 3 after the decimal will never end, we all know. Even if you put in calculator, it will show 0.333 and at the end it will show 3 only. But this number keeps on repeating in the same way. But it does have a sense because it can be represented in 1 by 3 form. That's why I have written directly 1 by 3. Even though it is a fraction, it has a decimal value and it is non-terminating type. Similar to that, there are also several numbers which repeats in pairs, like 0.45. This 45 will keep on repeating forever. There is also 22 by 7 and 0.3 also. So these numbers which keep on repeating in a what we can say in some similar fashion and in same pattern after the decimal, they are non-terminating and they do make sense. Apart from this, whatever number which does not fall in this category, they are known as irrational numbers. For example, let's say root 2 and root 3. I know many of you might have taken 1.41, 1.69 as the value for root 2 and root 3, but mind well, those are the rounded off values. If you put these values in calculator, you will come to know that these values don't have a repeating pattern and they don't even end. They keep on going forever. So like just like this number 0.136489, it will keep going in a random way. We don't know what pattern it will follow, but it will keep going. So we cannot make any sense of this number as such. That's why they are called irrational. You cannot make any rational decision or rational value out of this. Oh, let me just pick this call. Okay, I think you guys should also hear to this.
Hello sir, Alvin here. Sir, I understand that the numbers which cannot come in p by q form are irrational, but sir, 0.4545 it is not ending, so how do we represent it like rational? And even the integers, they don't have any denominator in bottom, sir. So I think there might be a typing mistake.
Okay guys, so I'm sure you might be, some of you at least, who are not from science background might be having this question, or those of you who didn't pay attention in classes might have this question, but let me show you how it's done. So we were talking about P by Q forms, right? Here it is. Now P by Q forms for terminating decimals, how do we convert that? Let's say I take a number 1.5. I will just simply add a 10 with the power equal to number of digits after the decimal. Like after, in this 1.5, I have only one digit. So I will put 10 raised to 1. So we can evaluate this and come to know as 3.2. That is its fractional form. Similar to that, let's take 3.69. It will have two digits after the decimal. So we'll put 10 to the power 2, like 100. And you can evaluate it later on. Similarly, every decimal that is terminating can be represented in the fractional form. Now what about the non-terminating ones? Like this 0.77, which will keep on repeating, 0.3 bar, it will also keep repeating, 0.21. This bar indicates that number is repeating. So how do we take care of this? I will show it later. That is part of our today's session. And next, integers. Of course, just add 1 as a denominator. It does not change any value. Even might it be positive, negative, or even 0. So whole numbers, negative numbers, everything, just by adding 1 you can make it in fraction form, because whether you multiply or divide by 1, it does not change anything. So it can be represented P by Q form or whatever form you want. So all of them are rational numbers. Now coming back to non-terminating decimals, I'm sure many of you might not be remembering or might be curious, but let me show you how it's done. Let's take our best example, 0.333, like 3 goes on. So consider it as a value x, y, z, whatever you take, whatever you like. But x is the most, as Elon Musk said, most cool letter of the alphabet. So let's represent it like that. Then I will just try to remove this 333. So what I can do, I will multiply it by 10 and then subtract them from each other. What this has done, the 0.333 which keeps on repeating is common in both of them. So by subtracting them, I have removed that repeating term and only left it 3. Now I can simply use the, division multiplication and solve it for 1 by 3 value. Similarly, you can also do for pairs, repeating pairs like 0.16. The only difference is for removing this pair, I will need to bring forth two similar numbers forward. Because if I multiply 10 in this case, I will be left with 616161, not 16. So that's why I will take 100 in this case and do the same operation here also. In this way, I will be left with 16 by 19. And you are free to solve it further if you can. Do let me know in the comment section what the final fraction you get. And just for one more sake of example, I will take 1.524545. Now here, if you will notice that 45 is the repeating number, not 52. So I will have to bring keep only the 45 after the number. That's why I will first take the multiple of 100 to bring that repeating pattern only after the decimal, and again a bigger number to keep that same pattern there. Now I can easily subtract them from each other and I will be left with this value. I think that makes it pretty clear now. Oh, again, but this time a different one. Let's see.
Hello, sir. Calvin here. Sir, I understand that these terms can be represented in P by Q form as they have said and indicated. But sir, doing such a lengthy process in exam is more time consuming, and it will, before we can, complete the question, our problem won't even be solved. So how is it helpful?
Okay. Of course, this is the most basic 7th or 6th class thing that I have shown you. So obviously you won't be using such a method in exam. So let's think how it is done in a much faster way, which I was going to show you anyways. So what is the shortcut here? Well, first you count the number of digits which are repeating after the decimal. You can call them anything. I will call them R, repeating ones. And you also need to count the number of digits which are not repeating, like let's say n non-repeating ones after the decimal if there are. Now what I will do, I will take the first set of unique numbers and subtract the non-repeating numbers from it and divide it by the r times 9. Like the number of repeating digits is 2, then I will write to 9 2 times, and it will be followed by 0, that will be equal to number of non-repeating digits. And I am sure none of you could make a single sense of what I just said. So let's see it using the same number that we took in the example, because this is a perfect set where there are non-repeating numbers, repeating numbers, everything. So number of repeating terms is 2, and unique number after the repeating terms are removed, first unique number, that will be 15245. After this we will get a repetition of 45, which we don't want. So this is our first unique number. And non-repeating term is 1, 5 and 2. It is completely non-repeating. So r is equal to 2 and n is equal to 2. Now we will simply do this operation. Unique number minus non-repeating number divide by the repeating term is 2 times. So I will write 9 2 times and followed by 0, which is the number of non-repeating terms. So I will also write 0 2 times. With that, after the operation, you will get this final value 15093. And if you go and check in the previous one, this value was the same. So this method, in simple 2 steps, you can directly get the answer. And I am sure many of you might not be confident if you have done this the first time. So let's do a few practice sets. Let's take these numbers: 1.3333, 4.53222 and such. So based on the last example, I am sure this is the most basic and you can do it. So I expect you to do this as a homework. We will catch up again in the next section, and I think 15 minutes are up. So let me know what your answers are in the comments. See you again in the next lecture, guys. Bye.